Hello everyone, my name is James Ferguson and this is a presentation for Advanced Industry Communication. Today I'll be discussing a critical issue facing one of Vancouver's most iconic landmarks, soil erosion on the Grouse Grind. I want to start with this image. What you're looking at isn't just a rocky path, it's a sign of failure. This is exposed infrastructure on the trail. When we see protruding rebar and loose earth like this, we have to ask ourselves, is the mountain crumbling under our feet? To answer that, here is our agenda. We will identify the problem area, analyze how erosion reached this state, and explain why it all matters. Then we will evaluate two distinct solutions, rerouting versus modifying the existing trail, before finally reaching a recommendation. Let's get some context. The mountain was named in 1894, but the grind as we know it was developed in 1981 by mountaineers specifically for exercise. Due to the immense popularity, it was rebuilt in 1996. Today, according to the Grouse Mountain website, it is known as Mother Nature's Stairmaster. It is 2.5 kilometers long with an elevation gain of 800 meters, that is roughly equivalent to a 200-story building. Crucially, because it is so steep, it is designated for uphill travel only. Unfortunately, that intensity comes at a cost. Current evidence of erosion includes trail widening, soil compaction, and the exposure of root systems. Research by Julia and Valescu confirms that conducting soil profiles reveals a heightened environmental impact where the volume of eroded material is closely correlated with the trail slope. If you look at these photos, the contrast is stark. On the left, we see the forest floor in its natural state. On the right, we see stripping away that natural cover. So why is this happening? It is a perfect storm. First, high usage by visitors. Second, the extremely steep slope. And third, heavy rainfall. As Favreau notes, water naturally takes the steeper, easier route downhill, causing sheet runoff to turn down the trail and cause erosion. You might ask, why is this a problem if it's just dirt? It's more than that. Erosion undermines infrastructure, reduces water retention, and weakens soil structure. Technically, if we look at trail sustainability ratings, a sustainable trail usually has a grade of 3 to 10%. The grind falls into the category 6, highly unsustainable. Sustainable design dictates locating the trails on a side slope, never on a flat ground or direct fall line. This brings us to solution number 1, rerouting. This involves using switchbacks to lower the steepness. According to Favreau, trails should follow the curvilinear alignment. Straight lines often result in the trail becoming a route for water instead of existing drainages. Here you can see the difference. The image on the right shows the proposed switchback route. Julia and Valescu found that the most noticeable morphological changes occur on direct descent sections compared to zigzagging ones, confirming that this layout would physically reduce erosion. Feasibility for rerouting is complex. It would require 12 months of work spread over 2 years. We would need specialty contractors utilizing high-angle equipment like this spider excavator. The advantage is clear. It provides long-term sustainability. However, the disadvantages here are massive construction costs and the fact that the purpose of the trail is fundamentally altered. Now let's look at solution number 2, modifying the existing trail. This approach uses 3 main tactics: rock water bars, adjacent vegetation, and hardened sustainable treads. Rock water bars are stone inlays that redirect rainwater. Favreau argues that while rock water bars require more maintenance than correct geographical drainage, if installed properly, they will last a long time. We would also plant native species. Hurian et al. Found that overlapping root systems of coniferous and deciduous trees create reinforcement zones that protect soil structure. Finally, we would apply crushed stone to the tread. Marion's research indicates that crushed stone significantly deterred soil loss on grades up to 12%, and even heavily graveled trails reduce loss on much steeper slopes. Additionally, Making treads more inviting minimizes lateral dispersion, meaning people stop walking on the edges and widening trails. Feasibility for this option is lighter. It requires more work during 1 month of the year, specifically the shoulder season month of October, spread out over 5 years, performed by Metro Vancouver crews. The advantages: no interruption to usage, it preserves the trail's purpose. While some may argue that hardened treads reduce wilderness appeal, clearly marked trails confine erosion to the main path, preventing degradation of the surrounding forest. In summary, while option 1 helps the environment, it destroys the identity of the grind. Therefore, my recommendation is option number 2, existing trail modifications. This significantly reduces erosion impacts while preserving the historic purpose of the trail. This brings me to the end of my presentation. Thank you for your time.